It wasn't supposed to leak, but it did. Schematics for Google's next-gen chip, the Tensor G5, have surfaced from inside developer circles. And what they show isn't just a chip. It's a new foundation for how AI could live with us, not just inside our screens. Tensor G5 is Google's first fully in-house chip, built from the ground up without Samsung. This time, they've handed production to TSMC and taken total control over design, thermal constraints, and software integration. Why? Because what they're building needs more than just power. It needs intelligence. At the heart of Tensor G5 is a redesigned neural processing unit capable of 60 trillion operations per second. That's enough for real-time language translation, semantic image recognition, and multimodal learning, all done locally. The cloud? Optional. One internal source called it Google's quiet weapon, because while Apple is shouting about the M4, Google is building something quieter, an invisible layer of intelligence that surrounds you without interrupting you. The chip is designed to support ambient computing, AI that doesn't wait for you to ask, but responds to your context in real time. Walking through a busy street? Tensor knows when to lower volume, shift audio profiles, and highlight key notifications, all autonomously. Its architecture includes dynamic model switching. That means devices can swap between small language models and larger multimodal models depending on use case and battery life without lag. This allows glasses, watches, and phones to operate like one distributed brain. Google is rumored to be integrating G5 into Project Muhan, its secret AR platform designed to compete with Apple Vision Pro. But unlike Apple, which emphasizes immersion, Google wants to build assistance, AI that enhances reality without replacing it. The G5 is also key to Google's federated AI future. On-device training allows Tensor-powered hardware to personalize responses and adapt without sharing raw data. It's not just more secure, it's more human. Reports say G5 includes a real-time environmental awareness stack, light sensors, sound detection, proximity sensing, and motion tracking, all processed through its AI core to deliver live context cues. One use case: smart glasses that highlight faces of people you know in a crowd, while delivering subtle vibrations when your name is called. It's interfaceless computing, AI that works like intuition. Tensor G5 is also expected to enable edge-based AI inference for future Android and Wear OS updates. That means things like health tracking, personalized coaching, or language translation could run 100% offline, with better responsiveness and total privacy. A leaked Google patent suggests the chip supports emotion detection, using voice stress analysis and facial micro-expressions to infer user mood. Combined with contextual awareness, this could let your device know when to offer help, or when to stay silent. Unlike other chips that isolate functions, Tensor G5 is rumored to have a unified AI instruction fabric, making every component smarter. The camera, speaker, sensors, and wireless stack all contribute to and benefit from a shared understanding of context. In terms of hardware design, Tensor G5 reportedly balances thermal loads using AI-based adaptive tuning. That allows devices to shift power dynamically between processes, reducing overheating in AR glasses and extending battery life without sacrificing performance. One of the biggest differences with G5 isn't just what it can do, but what it enables developers to create. Google has released SDK documentation suggesting new developer hooks for spatial AI, emotional modeling, and gesture-aware interfaces. This generation of Tensor could be the first to support Google's long-theorized Ambient OS, an AI-first operating system where apps run reactively in the background and only surface when contextually needed. Early benchmark results leaked to AnandTech forums show Tensor G5 outpacing Apple's M4 in raw AI operations per watt, while also maintaining better frame rate consistency under continuous load, key for wearables and XR systems. To protect user data, G5 will reportedly include a next-gen Titan security core. This enclave separates model training data from external access and encrypts sensitive inferences locally before passing them to UI layers. Tensor G5 isn't just a smartphone chip. It's the first step toward making every Google product intelligent, adaptive, and invisibly helpful. From Nest Hubs to Pixel tablets, every device will learn, anticipate, and evolve with you. Insiders at Google X suggest G5's roadmap stretches far beyond mobile. Concepts under development include car dashboards that adapt content based on driver fatigue, and in-home sensors that tune lighting and sound automatically based on emotional tone. One of the most anticipated use cases of Tensor G5 is wearable integration. Beyond smartwatches, G5 could power earbuds that dynamically adjust volume based on your surroundings and calendar context, lowering volume in meetings, raising it outdoors, and reading messages aloud while walking. Google's focus on minimizing latency and edge inference means Tensor G5 can deliver real-time response to voice, gesture, or biometric input. That makes the chip ideal for accessibility-focused features, like hearing assistance or navigation aids for users with limited mobility or sight. Industry analysts expect Tensor G5 to serve as the blueprint for Google's AI-integrated chip strategy across its hardware ecosystem, bringing unified behavior and adaptive logic to devices from Pixel Buds to smart thermostats. Unlike many competitors that separate sensor data processing from inference engines, Tensor G5 fuses them. That means a camera, microphone, and accelerometer can all feed into a unified model, interpreting events holistically instead of in silos. This enables more natural user interactions. For example, a user looking confused while searching for a contact might trigger a contextual AI suggestion, offering help based on facial expression, recent app usage, and location history, all without saying a word. Tensor G5 also improves sustained performance under thermal load. In early benchmarks, it was able to maintain AI workload throughput for 15% longer periods compared to Tensor G3, thanks to its adaptive throttling and power distribution network. On the AI software side, developers are being encouraged to build context-aware apps that use on-device models for prediction, scheduling, and real-time suggestion. With G5, this can all happen in under 100 milliseconds, a near thought-like response time. For creative users, Tensor G5 may also enhance mobile productivity tools. Google has demonstrated early builds of AI-assisted video editing and photo retouching that operate entirely on-device. No internet, no uploads, just raw creativity powered by local silicon. Education may be one of the biggest beneficiaries. With Tensor G5 devices, classrooms could host real-time multilingual conversations, science simulations, or writing prompts, even without internet connectivity, breaking through bandwidth and privacy limitations. Google's endgame? Seamless cross-device AI that doesn't feel like AI. That means subtle, adaptive help. Your devices don't just serve you, they understand you. And Tensor G5 is the first chip designed from the ground up to make that a reality. Tensor G5 is designed not just to process input, but to perceive. Engineers describe it as a foundational layer for predictive interaction, one that can model your intent before you even act based on biometric and environmental data. Imagine a Pixel phone that knows you're preparing to leave for work and proactively loads your podcast app, adjusts your thermostat remotely, and pulls up a navigation route, all without a command. This is what G5's multimodal fusion is aiming to make possible. In testing labs, G5 devices reportedly demonstrated 50% faster speech recognition in noisy environments compared to G3, thanks to real-time audio separation and a neural beamforming model embedded in the chip's audio stack. Another innovation is energy adaptive rendering. Tensor G5 can instruct the GPU to reduce visual fidelity in areas of the screen your eyes aren't focused on, tracked via infrared sensors, saving power while maintaining immersive clarity. For developers, this opens up a new category of UI/UX design: intent-aware interfaces. Rather than wait for user commands, interfaces could gently morph based on posture, speed of movement, or emotional cues gathered from biometric sensors. Tensor G5 also contributes to Google's sustainability goals. By reducing cloud server reliance for everyday AI tasks, it cuts down energy usage associated with data centers. It's a chip that could make personal AI both greener and smarter. AI literacy is becoming essential, and G5 is designed to support it. Google may integrate interactive learning prompts for users, allowing them to fine-tune which models are active, what data is stored, and how their digital assistant evolves over time. Perhaps most intriguingly, G5 could serve as the testbed for a new category of offline-capable AI apps. Developers are exploring AI diaries, mood trackers, and local LLMs that can guide users through self-reflection, health management, or even meditation, without an internet connection. Tensor G5 is the most ambitious piece of silicon Google has ever built, not just because of its specs, but because of its role in reshaping the relationship between humans and machines. It isn't just about computing faster, it's about computing closer. As the launch draws near, one thing is clear: this chip isn't meant to live in your phone. It's meant to live around you, in your environment, in your routines, in your life, and that could change everything. Tensor G5 isn't just designed for utility, it's engineered for creativity. In the hands of musicians, it can offer real-time generative music suggestions. For visual artists, it can recommend color palettes or enhancements based on subject matter and lighting, all processed locally. And for video content creators, G5 can enable rapid scene detection, automatic captioning, and noise reduction without connecting to any online service. It turns a smartphone into a fully offline production assistant. In enterprise environments, Tensor G5 could allow sensitive voice dictation or document summarization on device, ensuring no private data ever leaves the premises. This is a massive win for industries like healthcare, finance, and defense that are often locked out of AI advances due to cloud compliance rules. Perhaps most exciting, Tensor G5 is Google's first serious shot at truly post-smartphone computing. It's the beginning of an ecosystem where wearables, spatial devices, and home hubs coordinate quietly to anticipate and serve your needs. If Tensor G4 represented Google catching up, then G5 represents them leaping ahead into a world where AI is no longer just a tool you summon, but a presence that moves with you. Seen or unseen, it's always one step ahead. This chip isn't just fast, it's thoughtful, it's efficient. And if the leaks are even half true, Tensor G5 might go down as the most transformative piece of mobile hardware since the first iPhone chip. Tensor G5 may also pave the way for a new generation of developer tools powered by local LLM inference. Imagine mobile code editors that can autocomplete, refactor, and even explain logic without an internet connection, empowering developers in low connectivity regions or privacy-first environments. As Tensor G5 makes its debut, the real story isn't just about performance benchmarks or technical specs. It's about a tectonic shift in how AI integrates with everyday life. More personal, more private, more proactive. And it's arriving faster than anyone expected. Want to stay ahead of the AI curve? Hit like, subscribe, turn on notifications, and share this video with a fellow tech thinker. We break the silence around future tech, one myth at a time. This is Tech Mythos.